Okay, so welcome back everyone. So similar to on-premise scenarios, it is important to have your Azure Integration Services highly available. In this session, Toon van Hout, a Belgian Microsoft Azure MVP, will provide us the recipes for high availability and disaster recovery. Okay, so the floor is all yours, Toon.
Okay, so welcome. Thanks a lot for the introduction. So hi folks, my name is Ton van Houten. If I would be an ARM template or an ARM resource, it would look a little bit like this. So I'm an Azure architect, trainer and consultant, been awarded as an Azure MVP and also Microsoft certified trainer. If you want to get in touch afterwards, my contact details are over here, so don't hesitate to do so. I have also a little announcement to make. As of today, I'll start my own business in Azure coaching, Azure training, and Azure consultancy, yourazurecoach.com. So don't hesitate to go and have a look over there. So this session is all about availability. And why is availability so important? Well, in the end, it comes down to costs. It might be that your employees are not productive. It might be that your customers are not able to use your online services or even not able to post any orders. During my career, I had, unfortunately, also some issues at my customers. Due to an outage at Azure Integration Services, the airplanes could not take off because the customs documents were not validated. We had also empty shelves for the vegetables in the supermarket because the FTP server was down and all ordering was done through EDI just in time. And because the BizTalk server was down, we had the trucks actually queuing up at the entrance of the factory, and that caused actually a traffic jam and the police had to intervene. So availability is important. If you talk about cloud and availability, this typically is all about service level agreements. And if you look at the individual SLAs that Azure Integration Services gives, it looks pretty nice. But at the moment you start combining those individual services, you need to think about your composite SLA. And therefore need to multiply your individual SLAs, and you will end up with an SLA, at least a theoretical SLA, of 99.74%. This means actually 26 minutes of downtime per week, which is for many businesses really not acceptable. So how can you improve your SLA? Well, SLAs are typically defined on a per region basis. So if you can span your solution across multiple regions, you will increase your availability drastically. The calculation for the composite SLA becomes a little bit more complex, but no worries, I got you covered. I did the math for you, and we'll end up with 99.9993% of SLA. This is a 4 seconds of theoretical downtime per week, which is pretty acceptable in most cases. So it's very important when you start in Azure in general, actually, you need to think about your availability strategy, and you need to refresh that strategy every quarter to see if it's still valid to your business. The first pillar of your strategy should be high availability. And with high availability, I mean every measure you make and take in normal circumstances to make sure you remove single points of failure and you implement a redundancy in your solution. The first strategy you could take there is just relying on the high availability that Azure gives you within a single region. Because every Azure service has baked in high availability within the region, so that might be sufficient for your region. My preferred approach is actually to rely indeed on that single region, but to make sure that you think about resiliency and how to deal with that. Transient failures are native to the cloud, so make sure you can deal with that. Implement retry mechanisms with exponential backups, and make sure you have queuing to decouple your several systems. The last option you have is actually creating a full multi-region setup, so active, high available setup. And if you do so, you better take paired regions because they are optimized for that. So then you need to load balance, of course, all your messages across your two regions. If you implement your high availability strategy, be aware and think about your scope, because probably not all parts of your application of your integration landscapes are as business critical as the others. If we take, for example, an e-commerce website, it's very important that your website is live, so that people can still place orders. So also the queue where your orders arrive are still available. But then the backend processing integration towards your back office, that's maybe a little less critical because in the end, your orders can still be made by your customers, and okay, there will be a delay in processing over there. So think about the scope if you implement high availability. Disaster recovery is related to that, but that is making sure that after an incident occurred, you get your system back in an operational state. And an incident can be anything. It can be an Azure region that goes completely down. It might be, for example, an issue that or a bug that gets introduced in a Logic Apps connector, or it might be your own fault doing a wrong deployment or even deleting a database. Also, there you have several strategies you could take. The first one is just recreating your environment after the disaster occurred. So that means spinning up your Azure resources in another region and applying the latest bits to it. This might be quite time consuming, so you need to check if this is sufficient for your business. Another option is implementing a cold standby. There you already create your resources in your secondary region. You make sure that your resources are already provisioned. And at the moment of a disaster, you use your CI/CD pipelines to apply the latest source code on these resources, and you restore all the backups you have. And that way you can faster recreate your environment. The best option, but also the most expensive option, is to go for a hot standby. That means you have your passive region ready at every time. So every time you deploy on your primary region, you also go for your secondary passive region. You also update that region. And you need to have, in such a case, also active data replication, like Cosmos DB has, for example, because you need to make sure that your data is always synchronized towards your hot standby. Also, here again, think about your scope, because not every part of your solution, of your integration platform, is as business critical as the other one. Next thing you need to think about is, of course, monitoring. You need to be aware that there is an issue before your business gets impacted. So have monitoring on both the infrastructure and the application layer. And there are lots of tools in Azure available for that. You have Azure Service Health, Azure Monitor, Application Insights. Make sure you configure the right alerts and you have dashboards that give you immediately insights into KPIs of your solution. Last but not least, foresee the right procedures and be aware that this is a real team effort. Your team needs to be knowledgeable about the architecture and the disaster recovery. They can only be confident if the procedure is well tested and there's a lot of automation in place. And make sure this is a real team effort. So your team needs to be knowledgeable and available. If your business wants to run 24/7, you need to have people available 24/7. Make sure that within the team there are clear responsibilities and that you have privileged access rights, because by default you don't have access rights to production. But sometimes when escalation is needed, you need to get them pretty fast. So in the end, it's making sure that you have the right trade-off for your business, availability on one hand, cost and complexity on the other hand. If we now try to apply this to Azure Integration Services, let's first have a look at Logic Apps. This comes with some challenges. First challenge is the fact that Logic Apps has no backup restore option available. So there it's highly advised to deploy all your Logic Apps definitions with CI/CD through Azure DevOps, GitHub Actions, or whatever tool you use. So in case you need to recreate your Logic Apps, you can easily deploy them in an automated way to another region. So make sure even you're currently running in a single region, that region is at least configurable within your ARM templates. Second challenge is the fact that once a Logic App is running, you can never restore your Logic App in that certain state. I cannot solve that one, but you can have a design pattern for that. It's not because your business process might take, for example, 5 days, that you need to have a long-running Logic App that lasts for 5 days. You need to have a look and split your long-running business process into short-running integrations. In this way, you will be less impacted about this. A lot of the Logic Apps connectors have also some state. They keep, for example, the last time they polled for a message. That state cannot be replicated currently to your secondary region. That means if you're polling, for example, an FTP server, and suddenly you start polling in another region, you will pick up all the files again that you processed before. In order to avoid that, I would say, if you can, don't use any stateful triggers, but that's not always possible. If you use a stateful trigger, be sure you remove, for example, if you're pulling a file, be sure you remove the file when you start processing it. And that way you avoid a lot of duplicate messages. We are of course in a cloud context. That means there is an at least once reliability. So you can always in any case have duplicate messages. So that also means that you always need to think about idempotent processing towards your backend systems. There are some particular stateful aspects around EDI control numbers and AS2 hash values. Therefore, you get from Logic Apps some actions that can synchronize that statefulness from your one Logic Apps integration account towards the other one in your secondary region. So there you can use Logic Apps to synchronize your state across the regions. A little bit strange, of course, depending on Logic Apps for your disaster recovery. Last but not least, and probably you noted this already if you use Logic Apps within an API context, the URI that you get from APIs, from Logic Apps, sorry, is a quite complex one. It has a complex SAS token and all of that. So be sure within your CI/CD pipelines that you don't use that URI directly, but you always put it inside an application variable or an environment variable. So you can just point to your app setting and you don't use the complete URL. And with your CI/CD pipeline, you can make sure that in the right region, you're pointing to the right URL. Okay, that's it for Logic Apps. Let's have a look at Azure API Management, which has also quite a few options. The first one is it has the capability to run in a multi-region setup, active. That means that you use actively both regions. This is only available in the more expensive premium tier. And this only covers your gateway component. So if you're using, for example, the developer portal, that one is not included in the high availability. Be aware that in case your API management is internally failing over to the secondary region because the primary is somewhere stuck, then your secondary becomes read-only, so you cannot change your policies anymore. The synchronization between your two API management instances is completely done by API management. So you only need to deploy once to API management and they take care of the synchronization. And the same is true for the routing. So you get a DNS name from API management and API management does the routing by default. If for some reason you want to control the routing yourself with, for example, Traffic Manager, you can still do that because you also get the DNS name of the regional API management instances. So you can build your own routing or load balancing solution on top of that. Another feature that API management has available is a backup restore. Be aware that this typically takes, so full backup and restore takes about 30 minutes. So it's quite a long time. And you can only restore within a same tier. So that means you cannot have a cheap solution with, for example, a premium tier in your primary region, and then a developer tier in your secondary region and restore it over there. That's unfortunately not possible. Think also about if you do a restore of your API management in your secondary region, it might still point to some references in your old region. Because, for example, you might point to API management, to application insights or to a log analytics namespace. So be aware of that, and maybe you need some PowerShell to update those references. How can you configure the backup restore? Well, in the end, API management gives you an API and you need to do the plumbing yourself. There's a PowerShell module to do it, or you can use Logic Apps with managed identity to easily implement this. I'm a big fan of the API management consumption tier, but unfortunately it has no backup restore capabilities. The next option, which is actually an option that I really like, is just using CI/CD to make sure that your two API management instances are in sync. So instead of using the expensive premium tier, you can just use a lower tier or even the consumption tier and create two individual API management instances and use your Azure DevOps pipeline to synchronize the two. Important, you can only do this if you have a full 100% configuration as code. Because if a user starts creating subscriptions manually, then you will have an issue because your subscription keys will only be known in one of the two API management instances, so he will not get access if he gets redirected to the other instance. This is also a very good strategy for blue-green deployments, where you use one region for your production environment and the other region for your staging environment. You can deploy already your staging environment, you can test over there, and then you just swap your production and staging environment. In this way, you have a nice deployment strategy, but you're also testing, every time you deploy, you're testing your failover scenario, which is of course a very good practice. Let's talk about Service Bus. There, the disaster recovery feature is only available in the more expensive premium tier. It only covers the metadata, not the messages itself. So let's explain a little bit. What do you need to do? First of all, you need to create a namespace, a Service Bus namespace in a primary region and one in a secondary region. Then you can initiate pairing between the two. That pairing means if you create a queue in your primary namespace, it will be automatically created in your secondary. The same is true for your subscriptions and for your topics. You also get a DNS alias. By default, this DNS alias is pointing to your primary instance. So all your clients and consumers of your service bus, they need to use that DNS alias in their connection string. At the moment, there is an issue with your primary namespace. You can trigger yourself, you must trigger yourself the failover. If you trigger the failover, the pairing between the two service bus namespaces is stopped. But I think that will be the least of your problems. The good thing is also that, of course, your DNS alias is now pointing to the secondary namespace. So that means that senders of the message are now sending messages to the secondary namespace without the need to update their connection string. Also, the receivers are now listening on the secondary namespace. Be aware that this disaster recovery feature does not cover the messages itself. So that means if there are still some messages stuck in your primary service bus, they will remain there until you fail over back again. Or it might be that the disaster is that huge that you just lose them. So there's currently no RPO on the messages itself. The last one we need to have a look at is event grids. It has out of the box server-side disaster recovery to a paired region, so you don't need to do anything for that. But of course, you are typically publishing events to EventGrid and most probably also subscribing to events. There, you are responsible to implement the disaster recovery yourself. So, enough theory, let's put this to practice. I have a use case with me where we had a customer with the following requirements. It needed to be a cheap and cost-effective solution. They wanted to have public API endpoints, so security was important, but no VNet integration was needed. They wanted to have a low RTO, so they need to have a disaster recovery that goes quite fast to the other region, but a manual failover was still acceptable. So it shouldn't be blistering fast, but at least it should be within an acceptable time frame. And they wanted to go cloud native, so all the bits and bytes should be deployed in an automated way. So as a solution, we have chosen there for the API management consumption tier. It's a very cheap one. The first 1 million executions are for free, and it integrates very well with Azure Active Directory to secure your public endpoints. From a high availability perspective, we just rely on a single region, but we implement some best practices around resiliency. So using queues to decouple components and making sure you have your retry mechanisms configured. For disaster recovery, we rely on a hot standby in the paired region. So we make sure every time we deploy our logic apps and our API management, we deploy the primary region and the secondary region to make sure they are kept in sync. If one region would be completely wiped out, we still have our Azure DevOps release pipelines to recreate it from scratch. So this is the example flow, and this is an order import. So let's have a look at it in detail. We have orders, EDI orders arriving here in this storage account. We have a logic app pulling on the storage account, and if a new order arrives, it picks it up and passes the EDI order to another logic app, which is responsible to do the EDI parsing and to translate it into a generic canonical order. The order is posted on a service bus topic, and another logic app is listening to it. This logic app will invoke the order API. This order API is behind API management, and as a sample implementation, we've just used also logic apps because this talk is anyway about Azure Integration Services. This logic app will not do that much. It will just put the order on the storage account so we can do some testing. The good thing is I implemented some naming convention in the name of the order. The first part of the name will be the ESB region. That's the region that handles this first part here, the asynchronous integration. The second part will be the API region. So this is the region that handles the API part. I need to think about some things because I deploy also this solution in North Europe, my secondary region, but I'm not allowed to listen with multiple logic apps at the same time. Because if I would do that, every order would almost be processed twice, once in West Europe and North Europe. So that's not the purpose. Another thing, I need to remove the files when I start processing them. Because if I stop this one and start this one, it will pick up all the files back again. So this can be done by having a logic app that looks like this. You have the trigger, you get the content from the file, and you invoke another logic app that is responsible for the processing. After this step, you delete the original blob, or maybe you archive it if you want to have trace of it. The next thing is this logic app and also this one, and maybe even other consumers of your API, they need to know whether they need to invoke West Europe or North Europe. So we need to have some kind of a router, some kind of load balancer in front of it. So let's have a look at the options that Azure provides over there. Three main options. There are some others, but I think these are the three most important ones. You have Azure DNS, Traffic Manager, and Front Door. If you look at the price, Azure DNS and Traffic Manager are pretty cheap. Front Door is a little bit more expensive. It depends, of course, on the amount of traffic you have. And it has a lot more features than only routing. Be aware that Azure DNS and Traffic Manager, they work on the DNS level. So DNS comes typically with the time to live. So that's a DNS response that gets cached at the client side, which means if you're updating your Azure DNS, it will take a while before all your clients have the new IP address or the new domain name. So that means you don't have an instant failover, you will have a gradual failover. If you want an instant failover, I advise you to look at Azure Front Door because that's an active load balancer. Your HTTP traffic goes through this component. So you have actually an instant failover you can just swap in seconds. If you're using Azure DNS, you need to do the failover manually. So you need to initiate it yourself. While Traffic Manager and Front Door, they have active monitoring of the health of your backend APIs. So you can configure health probes, and they will be validated every second, not every second, but at least every couple of seconds, it's configurable. If Traffic Manager or Front Door see that your backend APIs become unhealthy, they will redirect the traffic to the healthy APIs. So this is an automated failover, and this will of course be depending on the routing logic that you configure. So both Traffic Manager and Front Door are good to have complex routing in an active manner. Be aware that Logic Apps has no health probes by default, so you should implement it yourself. Also take into account Azure Front Door is a lot more than only routing. It has a lot of extra security features, which of course results in a higher cost. So for our case, Azure DNS is more than enough because a manual failover was acceptable. Then last but not least, if we deploy our API management and our Logic Apps, we keep them in sync with our CI/CD pipeline. But this this API management and this API management, they both have the same policy, but they point to a different URL because you need to remain in the same region over there. So put this URI in a named value, and within your CI/CD pipeline, you can give that value a different value depending on the region you are deploying. So let's test this. Currently, I have the solution running, and we will look at this storage account where currently everything is processed in West Europe. So let's have a look. If I click refresh over here, this is the resulting storage account. And you should see every now and then some new orders coming in. I think every 10 seconds or something, we have a new order. And they get also automatically removed, except those two, but let me just remove them for the sake of clarity. But you see, new orders are coming in on a regular time interval. So currently we're processing here in West Europe. All right, let me go back to the slides and let's initiate a failover. So first, to do a failover, we need to swap the polling receive logic app. So we will stop polling in West Europe and we start. So let's give this a try. I have a script over here where I can failover to North Europe. So I disable polling in West Europe and I enable polling in North Europe. All right, Let me click on refresh over here, and I think we will have a small hiccup now in the order processing because, yeah, the logic apps, all the logic apps will have a cold start right now. Also, the API management, it's a consumption tier, so it's suffering a little cold start. So I think we will have a small hiccup, but after a few seconds, we should see here new orders coming in. Yes, indeed, where the first part of the name is North Europe, which means that the polling and the asynchronous processing has occurred in North Europe, while the API is still being processed in West Europe. So if I do a refresh over here, this should be fine. Yeah. All right. Let's get back to the presentation. Now we are in a little bit of a hybrid setup. We also need to fail over our API management. So this can be done by configuring Azure DNS to point to the secondary. If we will do that, we hopefully see that orders now pointing to North Europe _ North Europe over here. So let me go to Azure DNS, where I have here my API DNS records. It's pointing currently to the primary, and I'm updating it to the secondary. So this is api.yourazurecoachtraining.com. I click save. Just to be sure, we can have a look at the logic app that invokes the order API. And over here, you see indeed that I'm pointing to this DNS name. So now this DNS has been updated, but it's still being propagated to the Azure DNS services. So if I click refresh, we will not see an instant propagation of that region. So we will have to wait a little bit more because first the propagation within the Azure DNS service should happen. That typically takes about 60 seconds. And then of course the time to live of our clients should expire. And that's actually, I think the time to live is set to 1 minute, if I'm not mistaken. So let's return to the presentation and get back on a later state. So some lessons learned about this. In the end, it's all about risk mitigation. You never have a 100% bulletproof solution. So you always have dependencies like global dependencies like Azure Active Directory. We're using managed identity to secure our resources. So there you have a single point of failure. Of course, Microsoft does everything to make sure that that single point of failure is as high available as possible. The same is true for Azure DNS. It has 100% SLA, which doesn't mean it might be down one day. Also, don't use logic apps to monitor logic apps. We had once a nice solution where we use logic apps to send out notifications to Teams, to Slack channels, to send SMSs at night. But those logic apps were, we had an issue in our integration environment because logic apps was failing, but also our monitoring was failing. So if you do monitoring with logic apps, make sure you deploy them in a paired region so they are not impacted by the same outage. And foresee monitoring of the monitoring, which means configure Azure Monitor alerts with the default email capabilities so you get notified. If you're doing IP restrictions, make sure also your passive IP ranges are allowed. We once did a failover to the secondary passive region. Most of the things started working again, but we were not able to exchange EDI orders with our B2B partners because they only allowed the IP ranges of West Europe and not the ones of North Europe. Make sure if you have a failover script, and preferably you have a script and it's not manual, make sure you can run it as independently from Azure as possible, or Azure DevOps even. So preferably can you run it on your local host or somewhere on a job server that is in another region. You must have the ability to modify it, because we had once an issue where we wanted to disable logic apps, but that's just timed out because of the issues within logic apps. So if in that case you cannot modify your failover script, you're screwed. So make sure you can comment that section out and you can continue. Last but not least, do not rely too much on Azure Service Health. It might be that everything is nicely green, but your house is actually on fire. So Twitter is often a more reliable source than Azure Service Health. So as a conclusion, think about availability and make the right trade-off for your business, the trade-off between availability on one hand and cost and complexity on the other hand. Let's have a look at our failover scenario. And hopefully if I do a refresh over here, we should see that now orders are gradually being processed in North Europe. You see already some orders are in processed by North Europe. Some are still in West Europe. And this is just due to the distributed nature of logic apps. It has different clients, different instances running, so the time to live will expire on a different moment in time. So this is a nice example. You have the failover, but it's not instantly. So thanks a lot for your attention. If you have any questions, you can reach out to me on Twitter @ToonVanHouten. And we will also have a look to the Q&A if I still have time, Mohan.
Okay, Toon, so we only have 3 more minutes for the next session to start.
Yeah, okay, perfect. So I'll try to take these questions. There are not too many of them. So does Azure have high availability features itself? Yes, Azure has a lot of them, like availability regions and so on. So indeed, most of the Azure components within Azure Integration Services, they use and they leverage those features. But in the end, an issue within a region might still occur. And it's not always a complete region that goes down, but it might be sometimes just a wrong deployment. As an example, we had, for example, the FTP adapter that suddenly contains a bug. And in that scenario, yeah, you cannot use your FTP connector anymore because Azure is typically not deploying all the regions at the same time. It's important that you can recreate, in that case, your logic app in the secondary region. And typically that should be a paired region because paired regions are never deployed and upgraded at the same time. And that way you should be able to overcome that issue and then later on switch back again. I guess for the CI/CD option, the base URI will be different for API management. Yeah, indeed. So I hope this is clear now from the rest of the presentation. You will need to have a DNS or router somewhere in front of it. So or you use Azure DNS, or you use Traffic Manager, or you use what is it again, Azure Front Door, and then you can point to those DNSs of these services. Indeed, it's not the intention that your clients, your consumers will change connection strings. Why do we need high availability for IES if underlying Azure provides this? Yes, so that's a little bit the same like the first question. So Azure has those things like availability zones, also upgrade and error domains. Azure services try to implement them as much as possible, but still you have your limited SLA in your single region. So if you want to take benefits of multi-region and the highest SLA, you need to think about it. So yes, the cloud is high available, but it's not bulletproof. That's an important one. Any recommendation for the ICE? Well, actually everything I told you is applicable to ICE, but I understand that this becomes an extremely complex and also expensive solution. So there, I hope that Microsoft can come with a solution with now the capability in the future to run logic apps, API management and stuff on Azure Arc. We will have hopefully cheaper solutions to have high available scenarios and disaster recovery proof scenarios across multiple regions. So I hope that Azure Arc for Kubernetes can bring a solution to that. So that's it. Thanks a lot, everybody, for the nice questions and joining the session. If you have any questions afterwards, don't hesitate to reach out on Twitter. Bye-bye.
Covey.co